Oh, I need to get up. I have to meet Kiro at 9. But I live in the dorms, so no worries. For safety reasons, students now have to wait for traffic lights until the maintenance golf cars pass at two locations, Charwia and Busgate. No, I need to get up now or I will be late for Kiro.
Hey Ahmed, I'm about to reach the uni for us to shoot the video about graph theory. Where are you now?
Hey Kiro, I'm coming from the dorms now. However, I might be a bit late.
Come on man, you live on campus. How could you be late?
Didn't you know? The uni's administration announced new rules and regulations regarding traffic on campus. Students now have to wait for the traffic lights as golf cars' number has exploded.
Haha, now you'll suffer like I do. But it's actually a weird idea. Like, what if a student just decided to pass?
Unfortunately, they are going to impose fines on students who pass by Tarwiya while it is red.
Poor Ahmed. Wait a minute. I think we can model your problem using the graph theory concepts.
What the heck are you talking about? I don't want to be a vertex in your
Haha, don't worry, you won't. I was recently reading about the Fulkerson algorithm. Have you heard about it?
Are you kidding me? Get off my phone.
Ahmed, I'm serious. This is going to help you, and we can submit it at the same time for our final project.
Okay, then what's this algorithm is talking about?
It's an algorithm that is used to calculate the maximum flow of a network graph. You just insert the source node, the sink node, the adjacency matrix of your network graph, the capacity of each edge. And tada! It calculates the maximum value flow possible for this network.
Well, theoretically this looks nice. But how the heck is this going to help me not to wait for the traffic lights?
If we are able to know the maximum value of the flow, we can optimize the time of the traffic light so it doesn't get you stuck there for a long time while there are no golf carts to pass.
Okay, looks nice on a small scale like the uni's tiny lanes for example.
We can still apply this on a larger scale. I just noticed the same problem happening this morning with some pedestrians crossing the road while I was talking to you on the phone. It will only include more dynamic metrics. Let me put it in a clearer way. Take this city map for example. We will model roads as edges, crossroads as vertices, and traffic flow as the flow of the cars, that we also call capacity, through these edges. Imagine we, as the traffic administration entity, want to ensure that the maximum flow is more than or equal a threshold that we set. So, for example, imagine that the bottom left road comes from the town hall, and that the top right road goes to the airport. Today is an important day where many VIPs will go in a parade from the town hall to the airport, and we want to ensure that the maximum flow is not less than 200 cars. Now, we can use our project and algorithm to achieve several applications and solutions for such a problem. I will quickly go over some of them. Generally, the number of cars is more predictable than the number of pedestrians. So we will treat the car's time as the independent variable and the pedestrian's time as the dependent variable. Calculating the green light time required for the cars, we can reduce it, saving what is wasted and giving it to the pedestrians. Second, there are some lanes and road costs that are spent but not used. These also can be deducted and saved, but how's that? The algorithm, after finding the maximum flow from source to sink, tries to reduce the capacity of each road without affecting the maximum flow, and thus reducing the costs and the unnecessary lanes. Another very powerful application of this project is that it can reorganize each road flow to accommodate any unexpected road closures in case of accidents or construction work, for example. This can be done through setting the closed road capacity to 0 and rerunning the project. At each traffic light stop, we are treating the group of cars as a cluster, as one entity. We can then run our project with a slotted or unslotted timing. Let me explain. An unslotted version will have the similar timings as a whole, but the slotted version will have each similar timings split among different intervals, which is costly in time because of the switching time that we recognize as the yellow light time. Finally, another advantage that is clearly evident in the clustered unslotted version is that it might be easier on emergency vehicles to pass and move faster, as all the cars are clustered together in the forward direction, but also the opposite direction is totally empty. And the clustered unslotted timing would be incredible if all the traffic lights on the same road were timed together in synchronization to keep all the vehicles going at green light consecutively. And if they are timed in that synchronization, that would be also helpful not only to the emergency vehicles but also to the environment, because you are not making all the vehicles stop at several traffic lights, but they only stop once they join a cluster, but then they move in sync with all green lights on that road. So you reduce the time they are stopping and emitting CO2 emissions. I honestly believe that this project has a great potential. What do you think?
I'm not quite sure how you are going to do this, but we need to start now because the project is due today.